Login accepted.
Oh, wow. Like hacking and doing that like the CSI way. I wish it was that simple, to be fair. But welcome. Today we're going to talk about containers. And I see that a few of you are here are in the room already. And the room is bigger than the amount of people, which is still good. We have space. But who of you uses containers in their real life, enterprise kind of? OK, keep your hand up. How many of you use Docker containers? Oh, I see more hands. Like, I'm not using containers, but I'm still using Docker containers. Never mind, good for you, because we're going to talk about containers, and I'm doing that CSI kind of hacking, or at least I will try. But first, what is a container? It's interesting, because we try to mimic stuff from the real world into the virtual kind of software world, right? And if we look at a container, it can be, in the real world, it can be either your soda can or your beer can, your airtight container to put your food in, to store your food in, to make sure that it's good enough for the next day or the day after, or even more interesting in some cases, and that is how we display containers in a lot of ways, it's this, like the shipping container. And all these containers have something in common. The problem is, in the real world, a container is something that holds goods, a receptacle, so to say. And it is basically a barrier with the outside world to make sure that everything that's in there is preserved. Only if you use the right container, though. I mean, the can is there to preserve the flavors of either your soda or your beer to make sure that it's good over time. But putting your beer into a shipping container doesn't make much sense. Actually, in the same way, it holds for software. Pick the right one. However, people have this conception that if I put my software, my Java program specifically, in a container, by default, because it is a barrier towards the outside world, I am safe. It's more secure. Unfortunately, I have to disappoint those people. It is not. I mean, if we look at a Java container or a container holding your Java applications, it's not so much a protective barrier to the outside world. Why not? Because we need to interact with that outside world. We need to either have some user input, or else it would be useless to have a program in there. We need to get feedback back into that program because we need to connect to databases or other data sources. So it's basically an airtight container with holes in it, which doesn't make much sense because it's not airtight anymore. But you get me, it's a little bit different. So putting things in a container doesn't make it safe by default. Let's get to that. My name is Brian, and you see that this picture is pre-COVID. I grew a beard. You had to do something during COVID. I'm a developer advocate and long-time Java engineer currently working for Snyk. I'm a Java champion, do some stuff in the community, blah-de-blah, blah-de-blah, interesting. Anyhow, let's go into the interesting part, and you're here for a security talk with some spice. So let's talk Docker containers specifically. That's the easiest part. And why Docker containers? Because everybody's using them, or a lot of people using them, and it's a great example to just have a general talk about. Docker containers are downloaded massively. Currently, I think I wrote this slide like 6-7 months ago. It was 1 billion weekly downloads from Docker Hub. Images pulled from Docker Hub. Over 1 billion weekly downloads. That's massive. So let's talk Docker. And I will give you basically 5 tips not to fill your security for your Java applications within Docker containers, just to set the stage. First thing, I already talked to you like making sure that the container fits, making sure that the container that you use is applicable for what you need to do. So choose the right Docker base image for your Java application. Again, putting your beer into a shipping container without any other things doesn't make sense. This is most of the times the first thing that we do when we write a Docker file from Ubuntu or from something. Basically an image that you pull from Docker Hub or any other repository. Cool. But what does that mean? We're depending on stuff that somebody else put on the worldwide evil internet. and we're putting our stuff on top of that. So we inherit things. In late 2019, I did a research on Docker images, and I pulled the 10 most commonly downloaded Docker images that were free from Docker Hub, and we tested them for vulnerabilities. This was the result. All those 10 images had vulnerabilities, some more than others. And, well, we're at a Java conference. It's easy to make fun of Node, but let's not do that so much. The point over here is that because we inherit an image, and we did from Ubuntu, for instance, what does that mean? If I say from Node, I take the latest image from Docker Hub and put that as my baseline in my Docker image, and build my stuff on top of that. However, what am I actually using? If you look at this, these were all the latest images that I pulled, just to make an example, and not a specific hash or a specific version or whatever. We downloaded this and we looked at the vulnerabilities, and most of the vulnerabilities were on operating system layer. That means that if I have the Node image, for instance, it is also built on top of another image, and it's cascading. It's doing that over and over again. In this case, the Node image was built on a somewhat outdated version of Debian Jessie at that point in time. And almost all of these 500 vulnerabilities could be traced back to that operating system layer. So because an operating system layer can be outdated, you can have vulnerabilities in your application or in your container that you might not be aware of. But think of it for the other way around. If you have a very small microservice that you put in a container, do you need a full-blown operating system to let that work? Probably not. Think about it. Maybe it's good enough to make a smaller version. So if you look at the different operating system images, you see there's a huge difference in what they bring in. A lot of these images bring a lot of binaries in that might or might not be harmful. But think about the things like, if you don't need these things, do you want them in your application? What you don't have cannot harm you. And switching out your base image from a Debian-based image to a Debian Slim-based image already cuts down the amount of vulnerabilities. Think about it, maybe an Alpine one is even better if that fits your needs. It's a very slim image, not much to do over there, but if that fits your needs, maybe that's interesting. If we translate this to Java images, say adopt OpenJDK 11 images, we see that by default they give us the Ubuntu image. And that's quite okay. When I tested it, and this already is, again, a couple of months old, it was 25 vulnerabilities at that point in time. Fair point. But I could choose to use the Debian one, only it brings a ton of binaries in that I probably don't need, that have in some way a vulnerability. And then I hear you think like, yeah, but these vulnerabilities, they will never be touched. Are you sure? Every security vulnerability, every security breach is not a direct hit. It's a chain of events that eventually leads to a problem. Most of the cases, it's not just one thing. It is because somebody could in there, somebody forgot to switch on a firewall, somebody did this, connecting all the dots together, and if you have a vulnerability in there, it might be exploited. Okay, but what can possibly go wrong, right? Well, that's the first thing. Let me just try something. And I will just give you a small demo. So I am having, let me see if I do the right thing. I'm having a container here. I spin this container up just to see. Hopefully it runs. Building. And you see it's built on top of a Node 6 image, which is old, and that's why I want to do this. So let me give you the slides for a second. Let's see where I have this presentation. It should be here. So we're going to look at this problem. It's an improper input validation in image magic. And image magic is a binary that comes with Debian. Okay. I'm using an application that's built on a very old version of Node. And that Node image or that Node application uses image magic to do something. And the problem is this is already an old one, but just to set the stage, it is so famous that it has its own website, Image Tragic, which I find very funny, but that's up to you if you find that as well. The problem is the improper input validation. And a lot of things, because they are used somewhere and connected somewhere, initially they're vulnerable. So let's take a look at this. I have this application and it's spun up already. Cool. And let's go to this one. I think it's there. Okay, this is the application. It doesn't do much. I can get a file, an image file, and let's say I choose this image file. And what it does, it resizes the big image to an image that is suitable for Twitter. And under the hood, I'm calling ImageMagick, which is used, or which is a binary that's provided to me by Debian. Cool. So this works. But what if my image looked like this? I have an image, rce1.jpg, and it's not your common image. It's just like you can specify SVG files in a certain way with a view box. You can do that with JPEGs as well. And this is accepted by ImageMagick. However, as you can see here, I'm trying to fill this with a JPEG from a URL, which obviously is not there. Because of the pipe, I come back to the second part, and it basically calls the touch function in your operating system. So by uploading this image, I can create files, so it seems. So just to prove to you that I'm now connecting to that Docker image, and as you can see, RCE1, the file is not yet there. Going into the browser and getting that RCE1.jpg and resizing it doesn't give me anything back because that image is not there. However, let's see what happened here. And as you can see, I now created a file in the file system. And you're like, yay, empty file, ooh. But if I can create an empty file, I can create a file with content. I can create a script, I can call that script, and again, a chain of events that lead to whatever mayhem I want to create. And that is because I am using an image that is old, that has an old binary that I want to use for some reason. But if I updated that image to a newer version, I wouldn't have that problem. I inherit the problems from my predecessor that created the base image. I will come back later with some more interesting stuff, I promise you. All right, getting back to my slide deck. So we had this, but we already told you, like, pick the right base image, right? But then again, if we pick an image, we should only be using what we actually need. And that makes sense. But if you look at Stack Overflow, and like, how do I create a container for my Docker, or for my Java application? In many cases, you will find something like this. Like, hey, if it's a Maven project, just use the Maven 3 OpenJDK 11 or whatever image. And what I'm actually doing here, I'm having a base image that contains the full JDK and Maven. I copy all my source files to it, and I run a package, and I spin this off using a Maven target. Well, you could actually cut out the Maven package in this case. But think about it. Is this what I need to run my application? We use Java. That means the JDK is there to compile my stuff. I only need a Java runtime environment to run this Spring Boot application. So why, in God's name, would I create a container that contains Maven, the full JDK, my source file, and is over 800 megabytes big? You shouldn't. Not in production. But still, this happens in a lot of ways. So what can we do? Luckily, there is a mechanism in Docker to split images, and we call this multi-stage build. So you probably have heard of it, but you can split the way of building an image, if you want to do that in a Docker file, from the actual image that you want to put into production. So how does that look? Well, this is basically the same way. In the first part, you see again that it's that Maven image I used. But I now refer to it as build. So I do all sorts of stuff there, build my application, and finally, in that container, there is that jar. Then I build a second part, and that's the second part on my screen, and I create a image based on a Java runtime environment, in this case an Alpine one, because I don't need so much stuff. I basically copy the jar from my build image over to my final image and just call it Java-jar. So my end product will be a very small Alpine-based Java runtime environment image. And that's only less than 200 megabytes. Still a lot because, hey, Spring Boot. But you get me, right? You don't need all this stuff. If I have Maven, the JDK, and my source files, if somebody is able to get into my Docker container for some reason, he can probably stop the application, change the code, recompile it, start it all over again without pulling the image down. I see opportunities over there. Now it's not possible anymore, not so much possible because you need to recompile this stuff. And again, it's smaller, so it's easier to deploy, it's easier to run, etc., etc. One more thing. If you're using this, there is another benefit. Everything that is in the build image will not end up in the final image, the production image, if you don't say it so. So for instance, and this is a case that I need to provide, for instance, some credentials, like a username and a password to this Maven package file. Or I want to insert some extra things that I need just for build purposes. They will not end up somewhere in the cache of my Docker system, or of my Docker final image, because, hey, I'm not saying so that it needs to be. I'm building up a second image that doesn't contain these credentials or these secrets. So if you need to use secrets, you can perfectly fine use that in the build part. Cool. So we set the stage again that we should use multi-base images. So let's continue on that. Who has ever heard of the least privilege principle? It's a very, well, some of you. Least privilege principle, let me just cut it short. It's making sure that you can do what you need to do. Nothing more. Also nothing less, because then you have a problem, right? So only are allowed to do the stuff that you need to do. That means that I have a problem over here. Does anybody know what the problem over here is if you look at it from the perspective of the least privilege principle? Yes, exactly, I heard already. By default, Docker containers are run as root. Cool. That means they have more privileges than needed. And a lot of people just say like, I don't care. But if there's somewhere there is an attack factor in it, and I will show you that it can be either in your application or in your container, you are in there as root. So that means I've got God mode over there. Not what you want. So it's quite easy to set this up. And we only have to talk about this part, because that's the part that actually goes into production. So this is the answer. Well, let me highlight the lines for you. Again, this is an Alpine image, so the commands here might be different from a Debian image. But what I do basically, I create a group and a system user that doesn't have shell access or a home. I copy the stuff over, like my jar file, and then I set ownership to the project folder, because that's what I need to do for this application. Then the third yellow line, because the yellow lines are the only important lines here, because the rest we already discussed. The third line is very important. Calling that user. If you forget that, all the other stuff was done for nothing. You're just still running root. By using that user, all commands afterwards will be called by that specific user. So now it will be called by this user and only has the privilege to that part of the system that I want it to have. Think about other things, and it's not always documented, a bunch of base images that you can pull from the internet, and I know the Node.js image is one of them, already contain specific users. But you still need to call them in your Docker file. So that's why I said the third yellow line is quite important. It's not always well documented, but if your base image that you're using has already a specific user, please call it before running the application, or else it doesn't make sense. Just making sure that your application can do whatever you want. All right, quite obvious again. So let me get into the interesting part. scan your Docker images and Java applications during development. And let's say that development is an ongoing thing. Because we all know that if we do software development, it's not so much that we do this one time and then it's done and you never touch it again. Well, some open source projects that are in ghost mode are. But enterprise world, it means that somebody comes up, there's a new feature request, etc. So application development is an ongoing thing. And let's look at it from that perspective. We asked people in our research, the state of open source security, and it was already in 2019, like, when do you scan your Docker images for operating system vulnerabilities? These are the results. A lot of people don't, because, hey, if it looks stupid but it works, let's ship it. It works, because that's the only KPI that I need to preserve and that I need to make sure that works, because, hey, my manager doesn't know until something bad happens. What we can do, we can use tooling to scan our stuff. And obviously, I work for a company that does these tooling, so I'll give you an example with my tooling. Not saying you should use my tooling. Well, actually, I do, but you can use other tooling as well. But just as an example, because, hey, I've got this installed on my machine. First of all, what we can do is, for instance, I can pull an image like the OpenJDK latest image, and I can scan it with, in this case, Snyk container. I do a Snyk container test on that specific image, and maybe that specific image with a tag, and it scans it for you. That's how I got the numbers that I started with in the first place. Okay, interesting. So I know if this image is big, small, that contain a lot of vulnerabilities or not. So what I can see here is that if I see that I'm using an adopt OpenJDK 11 image latest that's based on Ubuntu, I see that in this case I have 21 issues in 132 dependencies known. Okay, cool. But I can make a decision if this is good enough for me or not. And I'm not using that just one time. No, you should do that constantly, as when you build an image, scan it to see if it still makes sense. Just like you do that with maintainability, scalability. Security should be securability or something like that. It should be in that same line, and you should be taking just as much care of that as making sure that your website is responsive enough. Because, hey, but that's what managers see, right? Security is a little bit invisible. Next to testing, you can also do monitoring. That means that if I have an image that I created myself, I can monitor it at the point I want to push to production. Because you create an image that contains an application, let's say a Java application, and at that point in time, you're pushing it to production, but when you push it to production, it's basically static. So you know what is the base image, you know what application is there, and if you monitor it, and say you just pull that data and, well, what we do is we just check it for you on a daily basis, and if something new comes up, because security issues are found daily, and what is good now might not be good tomorrow. So you want to be updated right away. So not saying like, okay, push it to production, just focus on the new stuff. We need to continuously do that. And if it goes to production, monitor it, either with my tooling or somebody else's tooling. But that's just the container part. Let's take a quick look at your application. Say this is your application. This is the full binary that you put into production. How much of that binary, and say this is Spring Boot application, how much of that binary is actually the code that you pushed to production, that you wrote? What do you think? Who thinks it's like 20%? Who thinks it's less than 20%? You are absolutely right. It's about like between, it depends on the application, and how much frameworks you use, but hey, regardless, just try to download, to create a Spring Boot application with the initializer, just create one endpoint, and then count the number of lines of code that you're actually putting into production, including all the dependencies. That's a lot. Of course, you shouldn't be doing that, but you get me. Because that small purple bowl is what you wrote, and we take good care of that, because who does code reviews? The rest of you does pair programming. Okay, cool. Fair enough. But we take pride in that. Nothing goes into production before somebody else saw it, or we just checked it, right? But how did you go with your dependencies? I just pulled it in because Stack Overflow told me so. And once it is in, does it ever go out? And we know that libraries pull in libraries, pull in libraries, and like goes several layers deep, right? We all know that. But how much care do you take for that yellow part? Don't answer that. The problem in most cases, and we researched it on different ecosystems, and in the middle there's Maven Central, because we took Maven Central as the base, just our benchmark. But say, take Maven Central and NPM. What you see is most problems are not so much in the stuff that you actually put into your manifest file, so your POM file or your Gradle file, or if you're a Scala developer, your SBT stuff. It is what comes implicitly. Because what happens if you download a Spring Boot starter? What is a Spring Boot starter? Spring Boot starter is, in most cases, just an empty jar with a new POM file in it, with a bunch of dependencies that is pulled in. So the indirect stuff, like several layers deep, there might be a library that is vulnerable to blah, 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 blah. You've heard this story before. But again, what can possibly go wrong? I will show you. Ooh, should be doing that. Real sound effects. This is live, not recorded. Oh, it is live. I need to get used to that, but it's live again. It's pretty cool. It also brings some issues with it, but still. Like I have to do real demos and not record it. Anyhow, I'm having an application here, and this application, hopefully it runs. Let me just run it. Pray to the Wi-Fi gods that it runs, because this application runs on Heroku. I'm not sure if you can see it, but in the top part is javagoofbrian.heroku.com. And this application is a very old application using Apache struts. Why would you use that? I'm not sure, but this is exactly the problem that happened to Equifax like in 2017. Because they were using this as a framework, they built their stuff on top of it. Something went horribly wrong because nobody took care of the dependencies anymore. What I can do, I do not even need to go into that application. No, I can just call a curl request with a specific header, because this version of Apache struts is vulnerable. And I will not touch anything except for pinching into the right point with the right amount of force with the right or weird header. And this is the header. And you might like, what? This is a content type. Like, see, this is the key, and this is the value. Who recognizes this content type? One. You should all recognize this content type. It is an invalid content type. That is the only right answer. And what does it do? Like with this invalid content type, for some reason this is the short version, I am allowed to utilize OGNL, the Object Graph Navigational Language in Apache struts. It's an expression language, and with that expression language I can call features, or I can call methods, or I can call, well, what I do here, for instance. I can call new objects. I can create new objects. And that is the interesting part over here, because what I do here, and let me enlarge it maybe so I can have it on one line. What you see here, I create a new process builder. And that process builder, I just feed it the bash. And that bash, I can feed it a arbitrary command that is here as a placeholder. So, what I do here is I use this header I just showed you, and I substitute the word command for the word env. And basically, env is nothing more than a command on Linux to show me the environment variables on this Heroku machine. I curl it, and as you can see, I pinch it to the Heroku application that you just saw. So if I do this, you will see that now I see the environment variables of my Heroku pod. And you see, okay, the environment variables, how bad is that? But if I can call the env, I can call files again. I can call files containing a body or some input. I can create a script, come back tomorrow or the day after, call that script. Good luck with you finding out what actually happened afterwards. Doing a postmortem on that is difficult. But interesting enough, I can see that the Java home. Well, let's use that in the next one. I have enough time, more than enough time. So, going into that application, and just sign up for a bit. My name, 1, 2, 3, 4, 5, 6, because I work at a security company. No, don't put it in my bond password. Don't do that. And this application, what I can do, I can create to-dos like, let's do something funny, like eat pie. Put it in 1970, and I am hungry by now, so give it a high priority. And what you can see what it does, it translates that pi sign into the ASCII representation. Right? And this is all your application. Regardless if it runs in a Docker file, well, it runs now in a Docker image on Heroku. It's actually a modified, but it's a container. What I see now is that my symbol is translated into the ASCII representation, and it uses the native to ASCII function that is available on the JDK. Cool. So I know that is called. What I can do as well, I can upload files. I can upload zip files, and these zip files are extracted. They are unzipped, and they will be put in an application. Okay, fair point. But say my zip file, we know that Java home, right? Say my zip file looks something like this. This zip file contains 2 files. A good.txt, which is just an ordinary text file. And the second one has this file name. This is what we call a path traversal. With the /// you go backwards into the path, all the way to the root. And then I go to /app/.jdk, which I just found out from my environment variables on Heroku, that exactly in that container, on that spot, there's the JDK. And I know that within the JDK in the /bin file, there's this native to ASCII thing, which I found out that we're using. Ooh, all coincidence. Of course not. So what I'm trying to do by unzipping this is trying to overwrite it. And that's because, let's just do this. Let's just go to, nope, not this one. Let's go to JavaGoof exploits. And by uploading the zip file, I see that the extraction worked because my good.txt is there. So what happened to the other thing? I'm using a library to do this, of course, because Java doesn't have an unzip function by default. We can inspect the zip entries, and we can see what the byte stream is, but we still need to create the new file and put that byte stream in it if you do it in purely Java. So we use libraries for this. And this library didn't check for the file name if it does a path traversal. Maybe, again, a improper input validation. So what we can see now, it might have done nothing, or, well, let's create a to-do. Hi, Devoxx. It doesn't matter what I put in, because every single thing will now be translated to muhaha gotcha, because I overwrote the native to ASCII file with echo muhaha gotcha. So that is an entry point. Again, I can override files, so if you have more binaries in your application that are harmful, I can connect all the dots together and make a marvelous attack that you didn't see coming. But, and there's a but, let's spice this thing up. I have 15 minutes left, and I can do this. So this application, I can also put it in a Docker file. And this application is a war that runs on Tomcat. So I created a, well, yeah, I can show you the thing if you want to, but say, let's show the Docker file. Let me enlarge this. So in the end, I'm using a Tomcat base image, and I put my stuff on top of that. Okay? So let's Docker compose, let's build this one. And it should be all in cache. Again, hopefully. Well, I'll take something to drink in the meantime. The point is, I'm now not attacking the application anymore. I am going to attack the image. And this image is a Tomcat image that has a problem. Let me show you the problem in the meantime, because this is what I'm going to do. I'm going to do an arbitrary code execution in this specific Tomcat image. And what happens is, this is the shortcut, it was possible to upload a JSP file to the server via a specially crafted request. This JSP could be requested, and any code in that JSP could be executed on the server. Fortunately for me, exploit DB. I didn't thought of this myself. It is published, but if it's published for me, it's published for you, it's published for everybody that wants to do harm. So this is the exploit. And the exploit, this is basically a Python image or a Python application that can do two things. The first thing is they test it by creating a payload, creating that specially crafted request, and just putting a JSP file in containing an output with all A's, just to test if it works. Then, what we can do as well is we can create a second thing, and this is the JSP that I want to insert. Basically, I'm creating a form. That form has a field. I can click on submit, and then you see that that command that is submitted goes to the runtime. That runtime calls a new process. That process will be executed, and we see the output. Interesting. So let's see if that image is running. Cool. So let's go to localhost 8080. Yeah, Tomcat, cool. / to-do list. It's exactly, it's the same application, only the CSS is not running. But who cares about colors? It's the application. And I'm not gonna call the application anyway. No, I am going to call these exploits I showed you. So because I don't have Python on my machine, I'm creating a image using Python to do this for me. I should be doing this before then. Packages, cool, it's there. So the first thing I can do is I can call check, which is basically the first request, showing you that the A's are there. And just to show you they're not there yet, I'm giving you poc.jsp is not yet available. You see, this JSP file is not here yet. It's like doing a magic trick. Look into the box, it's not there. You've seen it. But if I do this check, it will call that exploit that I showed you, and now poc.jsp should be there. It crafted the request, and all the A's are there. So I can insert JSP files without touching the application. Cool. So let's do the other thing. To show you that pwn.jsp is not there. But I can call pwn, that again crafts that request and uploads a web shell. So now, without touching the application, I have this. Root, because they forgot, or I forgot to put in a specific user. But I can do a lot of things. ls-l, just see what's there. These are the files. Let's see what the packages are that are installed. Basically, I have a web shell now. Because I used the wrong version of that Tomcat image. And not to waste a lot of your time, I scanned this using the tooling I showed you in the slides by doing a Snyk container scan on this specific image. And what we see is that there are some problems here. For instance, this is the exact problem, the arbitrary code execution is the problem that we could have found beforehand. But more importantly is, okay, but what should I do? Well, for instance, if we look here, and I think that is cool, currently I'm using this base image, Tomcat 8.5.21 Java Runtime Environment 8. It says by a minor upgrade to 8 Java Runtime Environment, which might sound weird, I get rid of this problem. And why is that? Because 8 is a symlink, or you can. I'm not sure what the real Docker comment for that is, but 8 is not just 8.0. No, if we look on Docker Hub, we see that Tomcat 8.jdk8 is actually a newer version of Tomcat, and it's 8.5.70. And that doesn't include that exploit anymore. So I can now say, like, hey, let's reload that application, let's rebuild that Docker container, and you can show that it's not possible anymore. But I hope that you believe me, because Wi-Fi sucks. No, but that's the whole point. But you get my point. By just updating that image, and by doing this while you are coding, while you are working on it, or once it is deployed, monitoring it, you know that these problems are there. And you also know that there might be newer base image versions. For instance, I also, and this is on the container, but here you see I connected the GitHub repository for that application. I connected it to our stuff. And if I go to the POM file for this application, you see that over here, this is exactly the struts exploit I showed you earlier that can do the arbitrary code execution by doing that curl request. So by doing this constantly, we are aware of these things, and we can fix them right away. Because already here it says, and I hope you can see that, hey, if I go to 2, 5, 10 or up, it is solved. And I was just lazy. I didn't do it because I didn't know. I was just looking at new features instead of taking care of what was there already. All right, I've got about 8 minutes left. So let's get into the final part. We should build images to rebuild. And that sounds weird. But say again, this is your Java image. This is your Java application. And probably you're using more than one version of it. Maybe you have 3 pods. And if you have Kubernetes, it is quite common that you have replica sets or whatever. So we have 3 of the same applications. What you want is and say we have proper logging and we can see what's happening in either of these pods. And if, for instance, something goes wrong, you want to be able to terminate it right away without being afraid that something that you need to persist is gone. So say we found out there's a hacker in pod number 3. The first thing that we want to do is, boom, making sure it's not there because, hey, at least it needs to do all the things all over again. I can get rid of the imminent threat right away. Still, it's there, and I can fix it, but I can at least fight it. But then you have to make sure that it was built in the right way. Again, what we want is to put a new one up. And again, in Kubernetes, it's quite obvious, and most people use that to have rolling updates that you just don't want to get down all the way. We just want to upgrade one pod, and then another one, and then another one, to make sure that the new stuff is there. So by building a Docker image, don't just lift and shift. I love that word. It doesn't say anything. But just picking up your monolith, putting it in a Docker container, and run it. Because in most monoliths, old-fashioned monoliths, there's a database, there's cache, there are log files. And if you put that in that container, if you blow that container up, it's gone. And it sounds quite obvious, but you should make sure that these are outside of the container. So if you build for containerized applications, for cloud-native applications, you should take care of that from the get-go. And that a container is something that is disposable. Because if something goes wrong and you found out that you need a newer base image, well, we found out that 44% of Docker images vulnerabilities can be fixed by just using a newer base image, just like I showed you with the example before. So you want to be able to do that right away when you see it, maybe even automate it to some extent. We asked people, how do you find out about new vulnerabilities in deployed containers? And 45% of the people said, no. Which is interesting, because it is a layer you depend upon, and you should take care of that, in my opinion. Also, 20% of the Docker images can be just fixed by rebuilding the same Docker file. Why? Because people use a lot of this. Let's take the latest image, let's use apt-get or whatever package manager to install, and we know that if I do this today, it might be different from tomorrow. Again, in the application I showed you, that symbolic link to 8JDK for Tomcat is different maybe tomorrow or the week after. And if you just rebuild your image often, while even your code may not have changed at all, you can get rid of these things right away. Only if you do that, I don't trust machines, so I always use the -- no cache option to make sure that I'm not hitting any cache. I should not have been doing that here because, again. So rebuilding images, even though you're not changing your code is an obvious thing to do. And if you say like, okay, I don't like this latest tag and I use a specific tag or a specific SHA hash, good enough. But then you should investigate if that specific image doesn't have any vulnerabilities that can harm you. And if you are way too lazy or you don't want to get into that, just make sure that you update at least often enough that you're not vulnerable to exploits that are in the field for a long, long time. Okay, let's summarize everything. First of all, choose the right base image. Make sure that you don't put in too much. Obvious. For a Java application, in most cases, we don't need the JDK, we don't need Maven or Gradle or your build stuff. In most cases, a Java runtime environment is enough. So pick that accordingly and use multi-stage builds to provide that. Don't run as root. Sounds obvious, still happens a lot, unfortunately. Other systems may not do it, but in Docker, root is still the default. Be aware of that. Scan your applications and images constantly. Not only while you're developing, but once you go to production, make sure that you're still aware of what is there in production and what are the new versions that you know that there is a threat, if there is one, but also that you are aware of maybe new fixes, and you can prioritize it as you see fit. And again, build to rebuild, so that it's easy to kill a container that is there in production and replace it with a newer version, a better version, or at least making sure if somebody's in there, it's not getting worse than it already is. If you want to know more, we created a Docker application cheat sheet for Java developers to see what you can do, and there are some tips that might be interesting for you if you like. I will publish the slides, no worries. Again, I've got a few minutes left. For now, it is Happy Dog Day, International Dog Day, so that's why Patch is there, our logo. If you have any questions, feel free to ask them now. Ping me on Twitter, stalk me while I'm walking around over here, and everything I showed you with the tooling, you can use for free, and you can try that out. Are there any questions? Or everybody's now fixing their Docker containers. That's also good. I'm happy that I inspired you. So for now, I will give you, that's what the Americans say, I will give you 2 minutes back. Thank you for attending this. Enjoy Devoxx Poland.